Okay, continuing on to our next skill, tangent lines and tangent line approximations. A really frequent question you'll see on the AP exam is write the equation of the tangent line, or use the equation of the tangent line to do something. So the equation of the tangent line comes back to this rule from Algebra 1. Memorize it, stash it in your pocket, write it on your walls. It's y minus y1 equals mx minus x1, where this y, so the second y, and the second x represent some point that maybe you were given the x and then you had to plug it into a function to find the y value. And then the m here in the middle is nothing more than the slope, which is nothing more than f prime of x. So whatever function you were originally working with, you're going to take the derivative at that x value, which is the same x value. Take the derivative first, then plug in the x value, and you'll find the slope. Notice that the y1 actually is just f of x, which is the y value, but the slope is f prime of x. So then you plug those in and you'll have the equation of the tangent line. 9 times out of 10, you do not need to simplify it. You're good leaving it in this form. The second thing that you'll see a lot is use the tangent line approximation. So for example, let's say I'm dealing with the graph of cosine. Well, cosine's graphs, when cosine is 0, the y value is 1. So when x is 0, y is 1. And then it fluctuates from there. It oscillates. And that's 1 period. It ends at 2 pi. In the middle, I have pi. And, pi over 2 is here, 3 pi over 2, and so on. So anyway, that's the graph of cosine. Now, let's say I was asked to use the tangent line approximation at pi. So here's what that means. The tangent line approximation at pi means find the equation of the tangent line first at pi, which just so happens to be a straight line. Y equals -1. And it says use that to approximate the value, let's say, of cosine of 3. That is a weird question, right? Cosine of 3? We're used to finding things like cosine of pi because I could plug that right in. But cosine of 3 is about 0.14159, right? It's off. It's not pi, but it's close to pi. So this is 3. And that's pi 3.14. So if I wanted to approximate the value there, that would be cosine of 3. I could use the equation of the tangent line at a nearby value, in this case 3.14159, and then plug in 3 into that equation of the tangent line. And what I would get is this value, and so I have a slight error. So the idea is, though, if you're close enough, your error goes down and down and down. And so that's what we mean with the tangent line approximation. We're going to find a nearby value that we can plug in easily. So if I'm dealing with the cosine x function, an easy value I can plug in is pi, and I might use that to approximate a weird value like 3. Here's another example. Let's say my function is something getting squared. So the function is x squared. The normal value I can plug in is -5, but I might use that to approximate the weird value of -5.1 squared. And so in general, when you're using tangent line approximations, you're finding a normal value you can plug in to your function, and then you're going to use it to estimate a weird value. Here's an example. So the question is, use the equation of the tangent line, or use the tangent line approximation at x equals 4 to estimate f of 3.9. So immediately I'm underlining that. That's my weird value. And the reason I'm labeling it like that is because we're not going to touch our weird value until the last step. Okay? So that's my weird value. And then this is the function. So our first step in finding a tangent line approximation is to first find the equation of the tangent line. So we need a point, which is x comma f of x, and we'll need a slope, which is f prime of x. So let's start by finding our point. So you have two options here. You could plug in 4 or you could plug in 3.9. But as we said, you can't use the weird value until the very, very last step. So we're going to start with 4. You always want to start with the normal value, save the weird value for the end. Okay, so we're going to start with 4, and plugging it in, my point is 4, that's my x, and then when I plug it into my function, f of 4 is the square root of 4, which is 2. Okay, that's my point. I'm going to highlight that. Next, I need my slope. So I need f prime of x. Well, if f of x is radical x, then f prime of x is 1 over 2 radical x. That is a formula that we've seen many times in the past. But I don't want the general slope. I want the slope at the value where x is 4. So next we plug in 4. And I get 1 over 2 times 2, so 1/4 is my slope. Now I have my point and my slope, so I can go ahead and plug them in to figure out my equation of the line. So I have y minus y1 equals m x minus x1. So from here, guys, what we've just found is the equation of the tangent line, basically. Now what we want to do is isolate our y, because that's going to be our answer. So we're going to move this 2 to the other side, and I'll get y equals 2, because it's positive, plus 1/4, because that slope was also positive, x minus 4. Great. So for the tangent line approximation, simply start with the equation of the tangent line, then isolate your y, and now we can plug in our weird value to approximate. So in this case, we have the tangent line now. Now let's just plug in our 3.9 in for that x, and it will spit out our approximate y value. So we have y equals everything the same, but now we're plugging in our weird value for x. And we'll simply solve. From here, it looks tricky because there's a decimal, but it's very, very simple. So 3.9 minus 4 is negative 0.1. I'm going to continue my work here. Now, keep in mind, do not do 2 plus 1/4. Order of operations says you multiply first. So let me repeat. Do not add these two numbers. That would be wrong. Your first job is to multiply 1/4 times negative 0.1. Now it's easier if we can rewrite this as a fraction. So as a fraction, take these notes. 0.1 is 1 over 10. 0.01 is 1 over 100. And 0.00, if you have 3 decimals there, then you're going to have your thousandths, just like that. It's good to memorize these because they make our math much easier. So 0.1 is 1 over 10, 0.01 is 100th, and so on. So if I'm rewriting this, I have y equals 2 plus 1/4 times negative 1/10, and then from there I can simply multiply across. 1 times negative 1 is negative 1, 4 times 10 is 40, and so I have y equals 2 minus 1/40th. And I'll do the fraction trick. 40 times 2 is 80, minus 1 is 79 over 40, and that's our approximate y value. So another way you could write it is f of 3.9 is approximately 79 over 40, and that would be your final answer. Okay. So now that we've seen how the tangent line approximation works, let's jump back a few steps and just practice some write the equation of the tangent line examples. So first, anytime you see write the equation or find the equation of the tangent line, you should be thinking y minus y1 equals mx minus x1. And since it's a tangent line, then we know we're going to have the instantaneous rate of change, aka the derivative. So that m, is the slope, which is f prime of x. Cool. And we want to write it to this function, f of g of 2x at x equals 4. So the first thing we want to do is identify our function. Since this isn't a basic f of x function, it's really f of g of, it's complicated. Let's simplify our life by just labeling this y. Trust me, AP test takers, this is a very important strategy. Label this y. So now, to write the equation of the tangent line, we know we need two things. A point, which will be x, comma, I would write f of x, but I know it's actually going to be the y value, not necessarily the f value, because I want the entire function. So we'll just plug in our x and our y. So the x is definitely 4, and let's plug it in to see what our y value is. Let's do a sidebar. Y equals f of g of 2 times 4, which is f of g of 8. So now we start on the inside first. Let's find g of 8. G of 8 is just the value when x is 8. G is 2. So I have f of 2. And now to find f of 2, I go to where x is 2, and I find the f value, which is 7. So the y value of f of g of 2x is 7. Great. The next thing we need for the equation of the tangent line is our slope. So again, we don't want to write f prime of x because f is just a part of this function. So I'll write y prime. The slope is going to be y prime, the whole thing, its derivative. So when I'm taking the slope or the derivative, if y is f of g of 2x, then y prime, well, it's going to involve a chain rule because notice we have a function on the inside. Then we have another function, which is the g of that. Then we have a third function, f of all that. So we're going to apply the chain rule a couple times. Remember, the chain rule says take the derivative of the outside function first, and then leave the entire inside the same. So I'm going to write g of 2x. Then you multiply that by the derivative of the inside now. Well, again, I have a function in a function. So let's take, again, the derivative of the outside first and leave the inside the same. And now we'll multiply again by the derivative of the inside, which is just 2. So we apply the chain rule twice. Once for the f, and then once for doing g. So that's the general slope, but we want the slope when x is equal to 4. So let's plug it in. We have f prime of g of 2 times 4 is 8, times g prime of, again, 2 times 4 is 8, times 2. Let's work on the insides first. Naya, go ahead, ask your question. Okay, so let's start on the inside. We're going to find g of 8 first. So g of 8, we found that earlier. It's the value of 2. So I have f prime of 2. And I'll just copy the rest. Now I need to find f prime of 2 and g prime of 8. So keep in mind, both of these are slopes because we see the prime. So be careful. Let's find f prime of 2. So go to where x is 2, and f prime is not going to be 7. We don't want the value. We want the slope. So looking around, the slope is going to be, it seems like, up 1 over 1. The slope is positive 1. F prime of 2 is 1. And then G prime of 8. Again, go to where X is 8. Go to your G graph. We don't want the value, which would be 2. We want the slope because it says G prime. So counting, we see down 1 over 2. That looks like a slope of negative 1/2. And we'll multiply by 2. Multiplying all across, these 2's cancel. We get negative 1 is our slope. So I'm going to call that my M, or my Y prime. Now, simply plug it all in. So we have Y minus, I have my point up here, and I have my slope down here. That's all I need. So Y minus Y1 equals MX minus X1. And we are done with that problem. Let's look at the next one. Very similar. Why don't you pause it here and try it yourself and hint, what strategy should you use to get started on the right foot? Again, they want us to find the equation of the tangent line. Hopefully you took a moment to pause and do the problem. Let's see. So first, we know that we need a point and we need a slope. And since we have a complicated function here, we have a function within a function within a function. We want to make our life simple so we know what we're talking about and just call this whole thing y. So the equation of a line requires two things: a point, which is our x and our y, and it requires a slope, which is going to be our y prime. So let's start with the point. X is -2. Done. What's our y value? Well, let's do a sidebar and plug it in. So what's y when x is -2? So we need g of f of 5 minus 2 times -2. All we did was plug it in here. So -2 times -2 is +4. 5 plus 4 gives us 9. So I have g of f of 9. Let's find f of 9. Is that the value or the slope? We want the value since it just says f of and not f prime. And so the value is 8. So we need now g of 8. So go to 8, go to your g function. Looks like that value is 2. So our point is -2, 2. Great, now let's do our slope. So we need the derivative of all of that. How many chain rules do you think will apply? So first, we take the derivative of the outside expression, which is g prime. Leave all the inside the exact same. So this is the inside. Chain rule then says take the derivative of the inside. Well, this expression has its own inside and outside, so we're going to take the derivative of the outside guy, which is our f, and we're going to leave the inside exactly the same. So chain rule says now, again, multiply by the derivative of the inside. And this time, the derivative of the inside is simply -2. So we've reached a stopping point. But we want the slope now when x is equal to -2. So we'll simply plug it in. G prime of f of 5 minus 2 times -2 gives us 5 plus 4, which is 9, times f prime again of 9 times -2. Let's find f of 9 first. You always want, when you have a complicated thing like this, you want to start on the inside. So what's f of 9? Let's see. Oh, we found that already. That's 8. So what we want is g prime now of 8 times f prime of 9 times -2. See if you can do these by yourself. What's g prime of 8? We want the slope. And it looks like our slope is down 1 over 2, so -1/2. And then we want f prime of 9. Looks like the slope is up 2 over 1. So that's a slope of +2 over 1 times -2. So these 2's cancel. gives us an answer of -1 times -2, which is 2. That is our slope. And now we have our point, we have our slope, so let's plug it in. We get y minus y1 equals mx minus x1. Since it's a double negative here, I'll simply make that a positive, and we are done. Great job. Let's do our last question from this skill. It says, if this is our function, use a linear approximation to the function at x equals 3 pi over 2 to estimate f of 8. So the thing, okay, so let's rewind. A linear approximation is another way of saying use the tangent line approximation. Linear line. And in calculus, we're generally referring to the tangent line. So it says use the linear approximation at x equals 3 pi over 2. So that's what we're going to use to come up with our formula. Our y minus y1 equals mx minus x1 formula. Once we've used it to fill that formula, we'll isolate y, get it by itself, and then we'll plug in 8, and that's going to be our weird value. The thing you want to estimate is always your weird value, because it means you can't find it directly. So let's do it. Let's start by writing our tangent line approximation, or a tangent line equation. So we need a point. Well, we'll use this point. So 3 pi over 2 is our x. And we'll plug it into our function to find our y. So let's do that, sidebar. F of 3 pi over 2 equals 2 cosine of 3 pi over 2 plus 1. Let's find cosine of 3 pi over 2 first. 3 pi over 2 is down here. That's the point 0, comma -1. And cosine is x over r, or r is equal to 1 on all of the axes. So x over r, 0 over 1 are just 0. So I have 2 times 0 plus 1, or 0 plus 1 are simply 1. That is my y value. Next, we need the slope. So that's our point. We need the slope. Well, if y is equal to 2 cosine x plus 1, then the slope is going to be 2 times negative sine, or -2 sine x, and that's it. So now we, into that, plug in, or I guess I should write f prime of, we plug in our x value, which is 3 pi over 2, and we get -2 times sine of 3 pi over 2. So I can use the same diagram, because that's 3 pi over 2. And sine of 3 pi over 2 is going to be the y over r, so -1 over 1, or just -1. And when we multiply that with -2, we get +2 as our slope. So let's plug in our point and our slope to get our equation of the tangent line. Y minus, y1 equals what am I doing? Equals mx minus x1. That's step 1. Write the equation of the tangent line in your tangent line approximation problem. Step 2 is to isolate y. So we're just simply going to move this to the other side. So I get y equals, that's a +1 now, plus 2x minus 3 pi over 2. And our final step is to plug in the weird value to get our final answer. This is going to be our final answer, our approximate y value. So y equals 1 plus 2. And instead of x, I'm plugging in 8. So let's see what we get. Well, actually, we're good. That is our final answer. Like I said, you don't have to simplify, especially on FRQ. You don't need to simplify. But if it's a multiple choice question and you don't see this as a response, what you should probably do then is distribute, simplify, and see if you can match your answers to one of the questions, to one of the options. And that's it, y'all.